Hi there, welcome to another video for Leaving Cert Ordinary Level Maths. Today we're going to continue looking at trigonometry and we'll be looking at sine, cos and tan. You'll be familiar with these again from junior cycle. Sine, cos and tan can only be used with right angle triangles. They're similar to Pythagoras in that. Pythagoras was used for the lengths of the sides in the right angle triangles, and sine, cos and tan are used for the angles in right angle triangles. You might be familiar with the Limerick Sokotoa, or silly old Harry caught a herring trawling off America, and these are used to help you remember the difference between sine, cos and tan. It's very important that you don't mix them up, so it's worth learning. Sine is the opposite over the hypotenuse. Cos is the adjacent side over the hypotenuse, and tan is the opposite side over the adjacent side. The hypotenuse will always remain the same, however, depending on what angle you're looking at, the opposite and the adjacent sides could differ. So in this example here in the salmon coloured box, angle A is marked. The side opposite angle A is across the triangle from it. The adjacent side to angle A is touching off it, it's close to it, it's adjacent. If angle A was in the top right hand corner of the triangle, the opposite and the adjacent sides would switch places. The hypotenuse will always remain the same. What does sine, cos and tan let us do? If we know the length of one side and the size of one angle other than the right angle in the triangle, we can find the length of any of the other sides. So what we need to do is compare the angle we know with the side that we know and the side that we want to find out. And then we use algebra to solve for the unknown side. Here's an example. First thing we do with all these questions is identify the right angle. So the right angle is here in the bottom left, which means the side opposite it is the hypotenuse, which has a length of 12. We also know one other angle in the triangle has a size of 58 degrees, and we do not know the size of the length of the side opposite it. We're going to solve for that length z. Examining 58, we know that z is the opposite side, and we know that 12 is the hypotenuse, which means that the left-hand side must be the adjacent. We're interested in the opposite and hypotenuse, so that will be sine. Sine is the opposite side over the hypotenuse. Silly old Harry. We can then fill in the values we know. So it's sine of 58, the angle 58, equals the opposite side, which is z, over the hypotenuse, which is 12. Rearranging this, we can multiply both sides by 12 to eliminate the fraction, and we're left with 12 sine 58 equals z, and using our calculator, z will work out to be 10.1765, or depending on what they ask for in the question, we'll probably round that to 10.18 centimeters. In our second example, again, let's find the right angle. It's up here at the top. The side opposite it is the hypotenuse, which we do not know and we're not interested in finding as there's no unknown value there. And we also know that one of the angles is 34 degrees. The side opposite it will be the opposite side, so x is going to be the opposite, and the side touching off it is going to be the adjacent side. We're interested in the opposite and the adjacent, so that means we'll be using tan. Tan is the opposite over adjacent, trawling off America. Filling in, for what we know, we have tan 34 equals the opposite side, which is x, over the adjacent side of 20. Multiply both sides by 20 to eliminate our fraction. 20 tan 34 equals x. X equals 13.49 centimeters. One final example then is in our third triangle here. Again, we examine what sides we know. We have our right angle. The side opposite it is the hypotenuse, which is A. and we know the angle in the top left is 20 degrees. The angle across the triangle from that will be the opposite side, and the side touching off it will be the adjacent side. Examining this, we know the adjacent and the hypotenuse, which means we will be using cos, which is adjacent over hypotenuse. Filling in what we know, we have cos 20 equals 6 over the hypotenuse, which is a. So here it's slightly different because we have the unknown value on the bottom of the fraction. Where we do the same, let's multiply by the unknown value at the bottom to get rid of our fraction. So we have a cos 20 equals 6. And now we want to get a on its own, so we will divide both sides by cos 20. So a equals 6 over cos 20. A equals 5.638, or properly to 2 decimal places, 5.64 centimeters. And that's sine, cos and tan. Hope you find it useful.